Now that we know a little bit about the structure of a blockchain and its components, we can explore how a blockchain is managed and maintained. How is data checked for reliability and then put into blocks? What keeps the network running? The answer to these questions is a process known as mining. Since a copy of the blockchain is stored on each computer on the network, data can be retrieved fairly easily and quickly. Additionally, this allows nodes on the network to act as reliable validators. These nodes are tasked with checking the reliability of information when a new block is being compiled by a block producer, the node selected to write the next block. This process is also known as reaching consensus or mining. The further the chain progresses, the harder it is to alter data, as each subsequent block would have to be changed as well. This would easily alert other nodes to this malicious action. Essentially, to change historical data that has been added to the chain would have to be rewound one block at a time. The first blockchain applications use proof of work as a consensus mechanism. In proof of work, blocks go through a complex, energy-consuming process of trial and error when they are trying to create a new sufficiently random hash in order to create the next block. Nodes try to be the first to guess a value that meets a specific criteria. The time and effort expended by these computers act as proof that they put in sufficient work needed to help maintain the network and is appropriately known as proof of work. The miner that solves an equation that results in the creation of a block receives a reward in the form of a coin or coins, creating an incentive for users to mine blocks. Block rewards also act as an incentive for miners to contribute to the security of the system. The higher the blockchain's hash rate, the more secure the chain will be. The more processing power a miner has, the more likely they are to write the next block and receive the block reward, because they are able to attempt to guess the most variables in the shortest amount of time. While proof of work was the first consensus mechanism used by a blockchain, many have criticized its main feature as a downfall. Massive amounts of energy are consumed in order to secure a blockchain, so others have explored ways of having a secure blockchain without expanding massive amounts of energy. New coins are constantly being mined, and the number depends on the specific blockchain's rules or protocols. Proof of stake has gained popularity as a potential alternative to proof of work by completely disregarding the race to find a specific variable. Instead, a node is selected to write the next block. There are different ways of selecting validators within proof of stake models, but the most common selection method is proportional to the amount of cryptocurrency staked. In other words, the more cryptocurrency that is staked by a node, the more likely that the node is to be selected to be the next block's writer, basically because that individual is deemed to have skin in the game. The theory behind proof of stake is that the more cryptocurrency one is willing to stake, the more stake that individual has in the success of the network. If the individual is found to be sabotaging the consensus process, their stake is either taken or they're warned by the network, giving block producers great incentive to correctly validate the next block. Validators are essentially betting cryptocurrency for the right to write a next block. In return, they collect either a block reward or transaction fees. Usually no new coins are minted, limited inflation of the associated cryptocurrency. The collection of fees are an incentive for validators to stake their own currency, making validators have skin in the game, or money to lose if they are found to be acting maliciously. This threat of losing your cryptocurrency helps ensure the security of the network, as it highly discourages actions that might compromise the blockchain. However, it's not always possible to tell if a user is acting maliciously or if a validator is just not participating when they are supposed to. Sabotaging the blockchain is very different than not being able to validate a block because of lost internet connection. As a result, those who commit these non-malicious errors are often given warnings or fined instead of having their entire stake taken on their first transgression. Some state that proof of work has its advantages over proof of stake. Proof of work consensus mechanisms are completely trustless, as adding to the blockchain does not require a single validator to write the next block. Additionally, trust is amplified by each node's ability to monitor the others, constantly watching the network for inconsistencies. No one individual has to be trusted for a block to be confirmed, since all nodes are double-checking the validity of a block's data when it's being formed. Proof of stake also has its criticisms. Validators are arbitrarily selected, and a certain degree of trust must be assumed in order for the network to run. In order to gain a stake in the network, a potential participant has to obtain the required coins or tokens in order to be eligible to be selected as a validator. Additionally, if validators are selected by the size of their stake, the ecosystem puts itself in a situation where the rich have the disproportionate opportunity to be selected as a validator and collect rewards, allowing them to stake even more and then repeat the process. Basically, over time, the rich get richer. As previously mentioned, a key part of a blockchain's architecture is decentralization. In order to maintain and add to this unique network construction, incentives must be provided to make sure nodes participate in the network as to continue the building of a blockchain. The main incentive for mining is the block reward that goes to the node that writes the next block, encouraging more competition on the network and contributing to the security of the chain. Additionally, mechanisms are installed to control the amount awarded as block rewards to create an economically viable network. We've already touched on the main two consensus mechanisms, proof of work and proof of stake. While many protocols use these popular consensus mechanisms, there are a few networks that use rather unique methods of achieving consensus. Proof of activity, used by Decred, combines the traits of proof of work with proof of stake to create a hybrid consensus mechanism. Some consensus mechanisms give advantages to those who transact their coins or tokens frequently, while others incentivize the holding of tokens. Additionally, there are many subsets of proof of stake, each having a different way of determining which node gets to write the next block. Mechanisms are different, but they all aim to achieve the same goal: incentivize behaviors that will maintain the security and integrity of their respective blockchains. In summation, mining is the process of creating blocks made up of valid transactions. Essentially, it is the process in which nodes come to a consensus on which transactions are accepted. The process of creating a block differs within each blockchain, but the most common mechanisms to achieve consensus are proof of work or proof of stake. Proof of work pits miners against each other in a race to see who can find a compatible variable the fastest, creating a competitive and secure network. Proof of stake selects between users who have staked cryptocurrency. If that user acts maliciously, they are warned or their stake is taken. If the selected validator writes a reliable block, they obtain the block reward. Now that we know how cryptocurrency is mined, let's look at some potential attack methods that could disrupt this process and how blockchains look to mitigate these attacks.